So hopefully everyone can see my screen. Welcome to the PC Swim and EPA Swim 5 groundwater modeling workshop. Again, as I mentioned earlier, groundwater is one of those topics that is not talked about very often. When we think about swim, EPA Swim, normally we think about stormwater, but very rarely do people consider the subsurface flow interactions, which can be very important, especially when you're looking at more of a rural project site. As well, you can use groundwater to represent RDII, or rainfall dependent inflow and infiltration in wastewater systems. So that's what we'll be talking about today. I'll quickly introduce myself. My name is Kat Finney. Some of you know me as Karen Finney. I did change my name informally just because Karen did not weather well in 2020, and I prefer to go by Kat. I've been at CHI for about 12 years. Before I was at CHI, I completed my master's degree at the University of Guelph. And that's where I met Nandana, who we shared an office with when he was finishing his PhD. And we've been working together ever since, and he is a fabulous partner in crime. So I will pass it on to Nandana to quickly introduce himself.
Yeah, thanks, Kat. Yeah, so I also, it's been 10 years since I joined CHI, so time flies. So yeah, I had a background in before joining CHI, and I did some consulting work before, a consulting company, and then went back to school and then joined CHI. So at CHI, my main role is research and development side, but then in addition to that, I involved with all aspects related to conducting workshops, technical support, consulting, and then day-to-day other work too. Yeah, so that's a brief introduction for me.
Thanks, Nandana. And I do similar things as Nandana at CHI. We are actually quite a small company, but I'll talk about that in a sec. So we're fortunate enough to be able to be involved in almost everything related to CHI. So that's definitely a benefit. We aren't pigeonholed. We have lots of options for where we want to go. I tend to focus on the training more as well. We're all technical support agents. Actually, I'm on duty right now. But luckily we haven't had any tickets yet, so don't worry. Okay, so before we get started, all the fun logistical stuff. Don't worry if you haven't downloaded anything and you didn't read the email, that's okay. The fact that you're here is great. So before we get started, you do want to download PC Swim. Now I realize some of you probably have an existing license of PC Swim, and you're welcome to use that one. You may want to check if it's the latest version, and I can show you how to do that. You just want to open your PC Swim version, go to File, Help, and there's a little blurb about PC Swim, and you should be using 7.4.3240, either the 64-bit or the 32-bit. If you don't worry, you'll likely have no problem. However, there are a few functionalities, and I don't think we use them for this workshop, but we may. So if you are using the other version or a different version and something isn't working, just get in touch with us and we can help you through the problem. So to download, if you are using your workshop license, you can have both. So if you have an existing license, you can also download the workshop license. Just make sure it's in a different folder location so you can have both. You have been provided with 2 activations each, so you can download PC Swim on your desktop as well as your laptop. Excuse me. If you do need a new activation or another activation, don't worry, you can contact us and we can provide it for you. So to download your license, you should have received an email from Laura Lee, and you want to click on the little download button under license details. And I do have to apologize, that email, I believe it said that we start today at 8:00 a.m. It's actually 9, obviously. So sorry about that for anyone who is perhaps coming from the West Coast and woke up ridiculously early. My apologies. Just going to make sure everyone is muted. If you can all spend a second and just make sure. Looks like you guys all are. That's great. Okay, so first thing to know, download PC Swim. You will need PC Swim for this course. The next step, because PC Swim or how the workbook will work or how the exercises will work is that we want to have PC Swim on the screen as well as a workbook. And I'll show you what that looks like in just a second. But in order to do that, we need to ensure that you have the correct settings, so your resolution is correct. If you don't have correct resolution, what will happen is PC Swim will cut off some of the buttons and you may get frustrated or you will get frustrated. So what I recommend, if you don't know how to get there, I usually have trouble. I usually just type in resolution in the little search bar in the Windows icon on the left. And it says change the resolution of the display. And from here, you can scroll down here. What we recommend is a resolution of at least 1600 by 900 pixels and a text size of 100%. So text size is here under scale and layout. And if you are using a different version of Windows, it might look a little different, but you should still have the option. The display resolution, we recommend 1600, minimum by 1600 by 900. I'm at 1920 by 1080. So I'm great. So make sure that you have a good resolution. And if you do find that perhaps you can't find one of the buttons, it might not be your fault. So don't be afraid to ask questions. We're very kind people, I promise. And we don't judge. We've heard all the questions and I've asked all the questions. So don't feel bad. Don't think that it's a stupid question. Just ask. This is has two objectives here. One is to show off my cat, that's Duchess. But the most important part is that I would like everyone to create a new folder on their desktop or somewhere that you know or can easily navigate to. And the reason is, as we go through the workshop, we're going to be going through a series of exercises. I believe there's 5 exercises for this course. So when we download the exercises, we want to put them in this location just so we know where they are and the files aren't lost in your downloads folder. So if everyone could just go on their desktop and create a new folder and call it PC Swim exercises. I already have one, so I'm going to delete that. So yeah, make sure you do that. Or somewhere that you know, if you're really good at navigating to your documents folder, whatever you need, yeah, do it. So some things to note. So attendees will have unlimited access to the course. So there's no expiry. So as long as you have an active PC Swim license, you'll be able to go through the course. So let's say a year from now, you finally have that groundwater project, you can go back to the course and find those materials. The exercises will update or be updated according to the version we're using. So they will update automatically and be relevant to the latest interface, but that will still be available. So during the presentations or the live presentations, there'll be 2 instructors. So you'll always have Nandana and myself. Nandana is the lead for this workshop. He is the groundwater expert at CHI, but I'll do my best to answer questions when they come up. We will be taking turns presenting and answering questions in real time. And then there will be a Q&A session at the beginning and at the end of each session. We're also recording the videos. I will edit them so you're not just listening to me talking about my cats for the first 10 minutes. And we'll put the edited version on the course viewer so you can watch them at any time. Some other things to note, during the live presentations, everyone has already done it. We ask you to mute yourselves just because it's distracting. You don't need to have your camera turned on. We'll probably have our cameras turned on most of the time, just so you know who we are and who's talking, but you don't have to. You can relax and you can roll your eyes and fall asleep or whatever you want to do or pet your cat or whatever. How the format of this workshop will work is there's 4 sessions. This is the first session, and all sessions will start with a presentation. And then from there, we'll either be following up with a demonstration, and then you guys will be working on your own through hands-on exercises. If when you're working through your exercise, you do get stuck, you have a few options. The first one is there is a discussion board in every single lesson basically, and I'll show you what that looks like in a sec. And you can type in your question in the discussion board. Everyone will be able to see it, and the instructors will get a notification, and we can answer it on the fly. If you're not comfortable posting your question out in the open like that, I'm like that. I'm not always confident. What you can do is you can email us at engineers@chaiwater.com, or you can email us individually. I will add a note later. Actually, maybe Nanda, do you mind adding a note just with our email addresses in the chat? And so what you can do, I'm Kat, K-A-T, with at chaiwater.com. And Nandana is nandana@chaiwater.com, and it's Nandana. But if Nandana puts that in the chat, you guys can contact us directly. If it's a problem we're not able to troubleshoot from just the top of our head, what we'll do is we'll invite you to a Teams meeting, and then you can share your screen and we can go through it together. So I do encourage you guys to take advantage of this. It is great one-on-one time, and we are very nice, and we'll more than likely teach you a thing or two. And when you get there on your own, you'll be better off. So don't be afraid to ask questions. There's no stupid questions, I promise. This stuff can be very complicated. Now for a tour of the course. Okay. Here's my course. So hopefully you guys have all made it to here, which is great. So we're in session 1, and each session, again, starts with the live presentation, and you should have a button to, I think yours says join the meeting on the host, so I say start the meeting. From there, we have given you the slides. So you're welcome to follow along. You can download them using this little download button and add notes or do whatever you need to do. Now, after this session, what we'll be doing is we'll be adding an additional lesson here, a link, and that will be where you can watch the video, the recorded video of this presentation. And then after each presentation, we will have a hands-on exercise. So in this case, we have a hands-on exercise. We're going to be starting off just with a generic exercise. It's not related to groundwater. It is somewhat, but basically using the automatic watershed delineation tool. I'll be doing a demonstration of this before the exercise. But when you get to an exercise lesson, you're going to see something like this. So in this exercise, this exercise illustrates how to use the watershed delineation tool, and you'll be given a K number. So it'll say once downloaded, so you want to download this. Click on the file to open the project. PCSim will automatically open and prompt you to save the files. Browse, click the browse button and navigate to your PCSim exercise folder. That's the one you just created in your desktop, and create a new folder called 1776. Okay, so I'm going to do that. Click on that to open it. Now this is a packaged folder, so it contains not only the input file, but also the associated files, documentation files, all the files you'll need. So we need to unpackage it. It's basically the same thing as a zip file. So what I'm going to do is I'm going to go to put it in my PCSim exercises, and I'm going to make a new folder, K1776, and I'm going to put an A because I think I already have one. And I'll click OK. And then you want to unpackage. Now, when you unpackage your model, don't worry if it's blank. That just means that you have to build the model from scratch. So what will happen is you'll have a workbook show up on the left. You can resize. And if you have 2 monitors, you can even move the instructions to the other monitor, especially if you have smaller monitors. Now, what you can do is you can use the arrow keys to go through the steps. And before we do that, the steps have been written in such a way where, and this is probably good for this group, I imagine a lot of you already have experience using PC Swim. So if you are fairly aware, or you are very good at using PC Swim already, you don't have to do anything. However, if you are fairly new to PC Swim and you want to ensure you're not missing any steps, what you can do is you can expand all. Click on the menu and click on expand all. What that does is it just expands all these little sub-steps. So when we have a step where it's pretty much like set the flow units to CFS, You may not know how to do that, so you would just click on the expand button, and then it would show you click on the simulation options and where to go and change that. You go here. We do also have screenshots available. They're the little Polaroid sunflower pictures, and you can click on them, and it should show you just what the step is indicating. Sometimes it's tricky just using words alone to know where a person is or where the steps are directing you. Now, by default, and this is something that kind of a relic of when this workbook was created, by default, these screenshots will open in Internet Explorer, regardless of what you have your settings set to for the default. That's a PC Swim thing. But what we're finding is that a lot of companies are now blocking Internet Explorer. So if you are one of those people, I don't think there should be very many of you, but there may be a few, especially if you're coming from Stantec or one of the larger companies. Please let us know as soon as you can. We do have a workaround you can use to view those pictures. So if you're not able to see them, let us know and we'll figure it out for you. If you aren't able to see them, don't worry. The steps will include all of the directions. So you don't necessarily need them, but they sure can be helpful if you don't know necessarily which button. Especially since there are a few buttons that can be found in each panel. So for example, this is a map panel. This is where we're going to interact with the GIS component, and it has a menu button. Then we have a table panel, which displays tabular data. 1 second, I have to sneeze. Nope, it's stuck. Okay. It shows tabular data, and it also has a menu button. Same with the graph and the profile. So it's important to know which panel you have or are working from, and the steps do outline that. And then you know which button to push. Just, excuse me, I just need to plow my nose. Allergies are terrible. Okay. So we've expanded the steps. We also have, hopefully we have some here. Oh yeah. So we also have notes. So if you see this little icon here, kind of looks like paper with some notes on it, you can expand and it will give you more information. Now the information presented there isn't crucial or isn't important for completing the exercise. It's just for, hey, little tidbit of information. If you're finding it overwhelming, if you're finding the steps to be difficult, it's taking all your brain power, don't worry, don't expand them. Do what you can, and make sure that you're comfortable and you're learning as much as you can. It can be overwhelming at first to learn any new software, so be kind to yourself. Okay, so that is that. If you accidentally close it and you're like, oh no, what do I do now? What you can do is you can click on the file, and PC Swim will automatically list the recent projects, and the most recent one was this one. You can double click on it and it will pop up again. Okay, so that is that. So those are the exercises. We do have the solution file for you as well. And the discussion board is on the top right, and you can create a new post. And like I mentioned, Nandan and I will receive a notification immediately. And as long as we're at our desks and it's not lunchtime, one of us will answer the question. And if, again, you're not comfortable with the discussion board, having everyone see your note, what we can do is we can have a separate Teams meeting, and you can email us separately at kat@chaiwater.com or nandana@chaiwater.com. Okay, so session 1 goes from 9 to 10:30. Now session 2 goes from 10:45 to 12. Now when you create a Zoom model using the software we use to make this the training, it won't let you set the times to be 10:45 or the 45s or the 15s. It has to be on the hour or on the half hour. So just because this meeting says 10:30, it still starts at 10:45. And I know that's a little confusing. If you join at 10:30, that's okay. I'll probably be there already just doing some tests so we can have a chat about my cats. If you don't want to chat about my cats, then you can join at 10:45. Again, we have the slides available for you guys. And after the presentation, we will post the live recording. So if you fell asleep or had to step out for a second, they'll still be there for you. Allergies. Okay. I'm actually glad this isn't a live workshop because I would be gross. Okay, so today we go until it says 4:30, but we do have a Q&A session at 4:15. So session 4, we have our live session, then we have an exercise, and at 4:15, Nandan and I will be meeting in a new Zoom meeting, and anyone who wants to join can. So this is a good time to talk about any of your projects, ask specific questions about your projects, or even ask about other materials available. There's tons of stuff out there, and let us know and we can direct you to where it goes. Or if you just want to talk to us more. We are hiring soon, so if you are interested in a CHI job, that's also a good time to talk to us. At the end of the workshop, we do have a survey, and we ask everyone fill it out. Once you fill out your survey, you'll be able to download your CEU or your completed educational units, and you'll get a certificate. When you get that certificate, just make sure your name is spelled right and everything is correct. And yeah, and we also, last but not least, we have a section for additional resources, and I've included all the videos for the presentations that you won't necessarily see in this workshop. So the hydrology quantity modeling, we have the full presentation here. This demonstration I'll be doing, but if you want to watch it again, I do have a polished version. As anyone who's tried to present a live demonstration, they don't always go well. This one went really well. So if you want to watch that one, you can. And yeah, lots of neat videos. So, and if there's something that you want to see there, or if you want some additional exercises, let me know and I can add them to the course. I have no problem doing that at all. Just because it's the full, it's only one day doesn't mean that you guys can't work on this afterwards. That goes for the exercises too. It's not mandatory that you finish each exercise after the session. If you find you're quite overwhelmed by listening to just the presentation, you don't have to go through the exercise. It will help and it will be beneficial, but it's not by any means mandatory. And we've tried to allocate enough time, but if you don't finish, don't worry, you can just continue from where you left off. Now, none of the exercise build on one another. So each exercise is its own entity. So if you do want to skip some and do some, that's fine too. Say you don't want to do the watershed delineation tool exercise because you've done it before. You don't have to do it. Okay, but it always helps. That is the course. Okay. Good. All right, so I was hoping Scott Jeffers would be here. He is one of our newest instructors. But now I mentioned that CHI is small, and indeed it is. We're down to about 11 employees right now. And but we do have a good presence, or a fairly large presence in the industry, which is neat. I really like that part about CHI. And how we do it is by having lots of friends around the world. So the top row, minus the last fellow, Scott Jeffers, we are all CHI employees. I'm the first one. Nandana's the fourth one. And the guy at the end, this is Scott Jeffers. He sells PC Swim on behalf of CHI. He works for his own company, but he helps sell to the US people. We also have people in France and in Denmark. We have people in Quebec, South Africa, China, Thailand, India, anywhere you can think of, Colombia, everywhere. And a lot of these people, they work for different companies. However, over the years, we've got to know them. We've learned about their PC Swim skills, and they've offered to provide help when we need it. So whether that be selling PC Swim or helping us with the training workshops, they're there to help us. So PC Swim is taught in quite a few languages all around the world, and not necessarily from the CHI instructors. So that's how we do it. Lots of friends. And maybe one of you have been thinking about making a little bit of extra money with training. That's always an option for anyone who has good engineer or good PC Swim skills. Let us know. So in case you don't know about CHI and PC Swim, I think most of you do, but just a quick introduction. We've started in 1978. We're an engineering consulting and software developing firm. Our primary revenue comes from PC Swim, and we're the sole developers of PC Swim. And we've been doing this for about 40 years. PC Swim is the spatial support system for Swim 5 and EPA Swim 2, or EPA Net 2. So basically, we have the shell that runs these engines, and the shell helps streamline building the model, inferring the results, displaying results, importing data, and all sorts of other things. PC Swim has been used in tens of thousands of projects around the world for large engineering firms, government agencies, universities, cities, all sorts of places. Now, we do have a number of branches at CHI. Our number one revenue, or the biggest one, is the software, of course, that's PC Swim. We also have training, which is what I manage, and that's why everyone's here today. We also host the EPA Swim community and EPA Net Swim, or EPA Net community, and that is basically where people can go. And I'll navigate there. I always start on our sports site. If you click on the resources on any of our pages, you can go to the various ones. So our community is here. You have an option between OpenSwim and OpenEPANet. We're learning swim today, so we'll go to OpenSwim. And this is where you can go to find archived discussions about all parts of EPA Swim 5. And this has been happening, or we've had the listserv since 1996. We recently, I say recently, probably 5 years ago, created this website so people could actually search through the archive discussions. We also have documented bugs if you find something weird in Swim 5, feature requests, example models. So there's lots of wonderful things here. Now, this site is specific to EPA Swim 5, so you can't say things like PC Swim or Mike Urban or XP Swim or anything like that. It's just related to the EPA Swim model, which is great. Now, for those of you who weren't aware, if you have an EPA Swim model, so all these example models, they'll have a little description. And then from there, if you go to the bottom, you should be able to download a model. When you do that, this is an EPA Swim model. However, PC Swim accepts EPA Swim format. So the input, they use the same input file. So if you have PC Swim installed, the model should open directly in PC Swim. And then from there, you can take a look. So this is an incredible resource, especially if you're getting started and you don't necessarily know how to set up, let's say, control rules. You can click on one and get a better idea of how it works and help set up yours. So that's an incredible resource. And of course, the knowledge base is too, and it's searchable. You can search. When you search, you can filter on your year. You can do a range. So you're not getting too old of stuff. Sometimes the 96 stuff is pretty out of date. So that's our community involvement. We also have the code viewer. You can view the code. You can compare the code with other other engines and see what the differences are. You can look at the code. You can make a comment on it if you want. There's all sorts of useful things you can do. And dig into the PC or into the Swim 5. All right, that's my blurb. We also have the journal, and I won't spend too much time on that, but again, you can go here. We have our journal. This is an OpenSwim, not OpenSwim, open access journal. And how it started is we also host an annual conference every year. And back in the day, we would get all the authors to write a paper. And then from there, we would publish all the papers in a monograph, and that would be a gift for the people in the next year. Since then, we have made all the articles and all the papers free to view and look at. So you can open it, you can view the PDF. They've all been peer evaluated or peer reviewed. There's a PDF. And they're all available related to modeling. So it's not just swim modeling. There could be all sorts of modeling. It's just water modeling. So it's quite useful. Lots of good stuff. And yeah, let's see if there's any pictures. Pictures can be expanded. You can look at it through HTML, or you can look at it through the PDF. If you do have a paper that you're interested in publishing, I know there's a few people who are at this workshop who have published, you're welcome to do so. You just need to submit a paper, and then from there it would go into the review steps. If you are interested in being an editor or a reviewer of papers, we do have a call for editors. You can let us know if you're interested, and all the editors get a complimentary registration to our conference. So if that's something that interests you, you can also put on your resume. It looks pretty nice. Yeah, so that's there too. We have the conference every year. I've met some of you guys at the conference, and it is a fun time, especially when it's live, or in person rather. This year and the following year, the conferences have been virtual, which they are still fun, but definitely that social aspect is not as good. However, the papers are still excellent, and you can still socialize somewhat, not the same. And we have consulting, of course. Our consulting normally falls under model review. However, once in a while, we do work with local conservation authorities and cities to try and develop something really cool. We often make custom tools and things like that. Okay, long story short. So about Sim 5, it's been continually developing since 1969. It's hydrologic, hydraulic, and water quality analysis for single event or long-term simulations. You can do urban and rural watersheds, so we'll be talking about rural watersheds today. And it can account for open channel and pipe networks, and most importantly, and why PC Swim uses the native format for the EPA Swim is that it's a public domain open source software. So anyone can look at the code and see what's happening in the background. It isn't protected by a black box. In terms of support, and I recognize the names, I believe we worked with a few of you guys. If you have a question or if you need help when you're using PC Swim, you would go to, actually I'll go to my website. You would go to support.chaiwater.com. And this is where we have tons of resources. So we have lots of articles. There's how-to articles, which basically go through step-by-step how to do a particular operation with screenshots. It's written very similarly to how the exercises are written. We don't skip anything. We've added notes. And what we also do is for all of these articles, if we get a technical support question and we're not able to find the answer within our help documents, what we do is we ensure we add that content. So that's why a lot of the articles have other notes, and these are all related to questions we've had in the past to try and help people out. We also have 2-minute videos. If you're like me, a very visual learner, I learn well with videos. We have tons of them, and we've tried to present every topic with one video, one how-to, and one general reference article. So depending on how you learn, we got you covered. If you have a question that comes up and you're not able to find the answer and you are panicking, but you don't have to be panicking. What you can do is you can create a ticket. Now, this is the agent view. So yours would look a little different, but basically you'd want to create a ticket, and then from there we would answer your ticket. And I don't want to show this person's ticket, so I'm not going to spend too much time on it. But basically you can submit a ticket and it should be answered within 1 hour of you posting the question, as long as it's between 8 o'clock and around 4:30 Eastern time. We're pretty good at that. And all of the engineers are technical support agents. It's not outsourced to anyone else. So Nandan and I are 2 out of the 4 technical support agents. So statistically, you may get us. There's a 50% chance you may get us answering your question if you post something. But we're all very nice, I promise. We also have additional workbook exercises if you are wanting to pursue other topics. And yeah, that's that. That's all I want to say for that. Oh yeah, we also have forums within that site where you can post feature requests. And then people can vote on them. On our Open Swim site, we do, again, I showed you this already. We do have the knowledge base, we have the code viewer, and we have spotlight research projects. So if you have completed something that used EPA Swim 5 and you want to post that, you can what these projects do is they give other people confidence that how they want to use the model has been done before and it has been done successfully. So it's good to have a community to reach upon to give verification that it's a good model for your application and what they found. Okay, so this is what we call cartoon land, and it's probably the nicest way I've seen the swim processes represented. We have a really nice graphic artist we work with, and she does a fabulous job. So in terms of the various processes, I won't spend too much time because we're going to be focused on just one part of all of the processes, and that is the groundwater. So starting at the top, we have our precipitation. It falls on the ground. From there, the surface has various hydrological processes. So you'll have infiltration, you'll have evaporation. Some water will be lost to or stuck in depression storages or little puddles. Some will run off, and what's left over, or what runs off, will become runoff and go into your hydraulics network normally. However, we'll be focusing on the groundwater component. So after the water infiltrates, then what happens? Sometimes it will be lost to the system. Sometimes you'll have a water table that will build up slowly over time and then start to influence the nearby hydraulic network and so on. So we'll be focusing on these interactions. So in terms of the swim process schematic, we do have, it's basically the same thing, just not as nice. We have precipitation going onto your hydrology, onto hydraulics, and so on. But today we'll be working on we'll be looking at these processes. So precipitation going onto our hydrology or our subcatchments, having a hydraulic component, and at the same time having the groundwater component, which is on the bottom right here, interact with both the hydrology and the hydraulics. And that's that subsurface water. And this is useful for what we'll be doing today. So watershed or rural areas where you have things like tile draining, where you have a lot of infiltration or where water was then directed somewhere else, for example, karst effects or an actual aquifer. And you can also use a groundwater component to represent your sanitary influences. So we have on the left, you see there's RDII, and that stands for rainfall dependent inflow and infiltration. That's basically water that gets into your usually wastewater network unintentionally. So it's from cracks in your pipes or loose connections and loose fittings. But right now in swim, you can represent RDII using a unit hydrograph approach. It's quite simple. It's a simplified approach. It basically examines your when you're going to see the influence and what percentage of the rainfall is going to get in. So it's not physically based. So for a more physically based model that includes those groundwater interactions, you can use groundwater to represent your RDII. And that's something that we'll be doing in this course. And that will make more sense when we get there. But yeah, so these are the processes we'll be working with today. There's tons and tons of applications, which I don't think I have to tell this group. Flooding and catch basins and LIDs, stormwater ponds, new design, flood forecasting, lots of things. In terms of the swim files, we have our input file. So that contains your actual model information. We have the swim engine, so that runs all the computations. Your report file and your output file, they have your results. Your INI file at the top, that's your settings file, what everything looks like. And then you can have optional time series data and interface files. Now, this is for Swim 5. So when you have a Swim 5 model, these files will all be included with your model. And what CHI has added is we've added a CHI file. And the CHI file is a project file, and that has related information, including the Swim 5 version, the continuity errors, the authors of the project, and things like that. And then we have also a SQLite database file, and that's used to draw the swim layers in PC Swim. So it's done on the fly. Previously, and in the past version, very recently, we've changed this. We used to have the swim layers as separate shape files stored with the project files. But what we were finding is that we were getting some syncing issues when people were working on their network. And so we've switched to using a database file to draw the layers on the fly when you open a model, and it seems to have corrected that issue we're having. If you do have any concerns about this type of format, let me know and I can show you workaround for, you can still work between GIS applications. So if you do want to go to AutoCAD and then back to PC Swim, there's a really easy workflow I can show you how to use. I'm not going to spend too much time on this because I am aware that a lot of you do have some PC Swim experience. But just starting at the middle, we have a GIS engine built into PC Swim. We also have a time series manager. We have a Python scripting editor. We support the Swim engines going back all the way to 5.0.013. I think we're on 5.1.015. I don't think that's right. We have the EPA.NET engine. We also have tons of workflow support. So on the left, we have project management, model development and discretization, calibration and sensitivity analysis tool, output visualization, design optimization, real-time forecasting, reporting, documentation, and so on. We've also tried to make it as easy and streamlined as possible to import and export into the various other formats like Excel and GIS and things like that. And for other modeling files, let's say you have like a Mike Urban or an XPSwim model, we do have Python scripts available to help you convert those files into PC Swim. So we've done lots of effort to ensure that you can leverage whatever data you have, whether it be a GIS layer or a model from a different format. So if you do have that situation and you aren't quite sure how to get your modeling data into PC Swim, let us know and we can point you to the right direction. We also have a variety of specialty functions, including radar rainfall processing, flood inundation analysis, and we have a 2D modeling component. We also have our own swim engines, which we've edited the EPA swim engine to include erosion and alternative runoff methods. So if you wanted to use a rational method, for example, to calculate your runoff, as opposed to using Swim's linear reservoir model, you can. And I think, yeah, this is the last slide. So in terms of differences with other stormwater models, we do have that strict adherence to the public domain open source engines, so EPA Swim 5 and EPA.NET 2. This means if you are using EPA.NET or if you are using PC Swim and your company decides it's too expensive and they don't want it anymore, you should still, or you will be able to open your model still in the regular EPA Swim 5. We do have that built-in GIS engine, so you don't need another GIS engine installed into your computer to use PC Swim. It does have complete time series management as well as tools to go along with it. And the technical support is done by CHI's engineers, so people like myself and Nandana. We do have a lot of community involvement with OpenSwim and the code viewer, with research projects. We have the journal, and we have our conference, and that's in February if you're curious. So that's my intro. What I'll do is I'm going to move on to a demonstration. And if you have any questions along the way, feel free to put them into the chat box. And if Nandana isn't able to answer them, I can answer them at the end of the demo. Okay. So the first demonstration I will be doing today is showing the watershed delineation tool. So this is useful, and we're starting with this because it's a practical first start for rural or large watershed scale model. So in this case, this is in Nottawasaga Valley Conservation Area, that region. It's in Ontario in Canada, around this area. So we are right here. I'm presenting from here, so it's not enough. So it's in this area. Excuse me. I'm going to turn off Bing Maps for now. And this is a DEM or digital elevation model. So at the bottom of the screen here, you'll see I have an X and a Y coordinate. And then when I move through this raster model or this raster layer, you'll see I have a Z or a Z coordinate as well. And that's pertaining in this case to my elevation. That allows me to, I can use a ruler, I can measure, and I can see what the elevation looks like because the DEM's there. If I turn off the DEM and I scroll over it, you can still see I have that Z or Z coordinate. So what I want to do is I want to essentially make a model out of nothing. Right now I have just 2 background layers. None of my sim layers have been populated. So I want to create a model from scratch. Just one sec. Excuse me. And how I'm going to do this is I'm going to use the watershed delineation tool. And this can be found in our tools under subcatchments. And I'm going to go to watershed delineation. Hi, sorry, my cat is needy. Okay, so in your watershed delineation tool dialog, you'll have to specify a few things. Your DEM layer or your digital elevation layer, which if you only have one, it should detect it, know which one. My burn and stream layer, you don't need to have one, but it can be handy, especially if you have like things like culverts or anything that can basically disrupt the natural flow when looking directly on the surface. So if there's a culvert here, for example, and that flow path isn't obvious, then it's a good idea to have them. One thing I often do is I will use a streams layer, and then I'll actually draw in culverts as well if they're not included. So what's going to happen is PCSwim is going to make a copy of this DEM or raster layer and basically carve 100-foot or 100-meter trench through the raster, so that flow path is very obvious when the subcatchments are discretized. So I will add that. Target discretization, how big do I want my subcatchments? In this case, I want them to be around 25 hectares. And I will push go. Excuse me, allergies. And then you can wait a bit. And what's going to happen is PCSwim will be drawing not only the subcatchments, but also adding a hydraulic component, so all the links and nodes. And why it's doing that is it's ensuring that every subcatchment has a junction directly downstream or a node directly downstream to drain to. So that way we don't have flow, for example, here, or that's not a great one. Here, it doesn't automatically have to fly to further downstream. So it accounts for the travel time a little bit better. Okay, so what are we looking at? We're looking at regular subcatchments, junctions, and nodes. So all the subcatchments were created, and they're based on their drainage boundaries and the topological features detected in the DEM. And then we also have our hydraulic network. Now, when the hydraulic network is initially made, all the cross sections are assigned to be circular 1 meter, 1 feet, depending on if you're using US or SI units. And it will just be a circular conduit. However, in reality, when you use your measure tool, it's not a conduit, it's actually a channel. So what we want to do at this point is we want to be able to sample the DEM, all the transects, and then from there assign those transects to be the shape of this conduit. And when I say conduit, it's just because PCSwim or Swim5 calls any open and closed channel a conduit. So it can be a conduit, it can be an open channel. So that confused me at first, but I imagine you guys all know that. So what I want to do is I want to use something called the transect creator. That's here. And I'm going to first draw my transects, and then I'm going to apply my transects to my conduits. So there's 2 tabs, 2 steps. The first one is creating the transect lines. So it asks for where my DEM is. I have that. My channel centerline layer, in this case, I'm going to use my conduits. Transect layer, I don't have one, so I'll create one here. Transect spacing, I'll leave it 100. And transect length, hold on, I have a screenshot. I was tinkering with this today. I found we have a range, and why we have a range is because the transects will be shorter at the upper portion of the watershed, and as you get further down and there's more water collecting in the streams, you're going to have larger transects. So I'm going to go 400 to 1,000 meters. So ideally, it will start with 400 up here, and as it goes down, they'll get bigger and bigger and bigger. Auto shorten transects, so sometimes when you sample the transects, you'll get 2 channels. One's a main channel, one's a secondary channel. So to ensure that I only have the main channel, I'm going to specify to auto shorten transect length to max left and right elevation. You don't have to, but I find it helps. And this is my filter. This is a standard deviation value. So basically what's going to happen is there's going to be multiple cross sections drawn across each conduit. And the transect filter will compare each transect to all the other transects sampled for that conduit. And depending on how well they line up with the other ones, PCSwim will either mark them as use or not use. And that will be based on your standard deviation. So you can change this value, and you can change it after the fact if you want, but I'll show you what it looks like. I'm going to keep invalid transects and click create. Okay, so you'll have an error report. That's usually indicating where the transects weren't complete. They didn't go up and down nicely. They just kind of went flat, or maybe it was off the DEM. So that's okay. And then this is what you got. You kind of get this squirrely mess. Now, when you zoom in, you can then click on your transects and see what the shape is. So this is my conduit. I have two transects crossing this conduit. And so when I click on one, you can see there's two of them being shown. The one in blue is the one I have selected. If I select this one, it will select the other one. And these points are basically what are being used to determine if the transects will be used or not, using that standard deviation. So for example, this transect has 2, or has 3, 1, 2, and then we have this one, 3. And 3, it's gray, which indicates that we're not using it. And if you compare it to the other 2, it is quite a bit different. So we're not using that. If you want to use it, sure, you can use it. You can just change it. And that's the same all around. Now, when I was using the transect creator tool, maybe I'll just go back there for a second. I didn't use this option, and that is the number of flow lines. Here I have 4, that's default. And the flow lines are these ones. We have the blue ones on the left and the red ones on the right, and a center channel. So you can have lots of flow lines. And basically what that does is it prevents having kind of like this mess, having transects, actually did a good job, not crossing one another. So it will draw the line by snapping to the closest point on the flow line. And the flow line is basically the center line, but smooth. And you can control all that. So it does take a bit of time, a bit of iteration to make sure that you have selected and you have sampled the DEM correctly, and you've sampled the whole transect and so on. So once you're happy, you spend a bit of time, and now you want to assign the transects to your network. You can use the second tab, which is transect object. So we have our DEM, our transect layer. I don't have an overbank layer or a roughness layer. There's 2 options. One is to split at every transect location. I don't recommend that. What's going to happen is you're going to get tons of tiny little conduits and you might have continuity errors. Instead, we're going to average the transects to each conduit. Push analyze. It's saying that they're closed conduits. You'll have to change them. I'll change them. And then you get your report. So I'm going to turn off my flow lines and my transects. And if I click on one of these, you'll see that now we have a lovely transect. Okay, so I have a few minutes left, so I'm going to do one more thing with this model, and that is I'm going to run it. So I'm going to go to my graph panel, and I'm just going to make a fake storm. So I'm going to use type 2 SCS storm, and I'm going to make 60 millimeters. We're going to make a good event, and I'm going to run that. I'll run that first. Have some tea. Okay, so it's mad at me. That's okay. It's always good to see what happens when things don't go right. When things don't go right, and when it doesn't run like that, you want to go to the end of the file. Usually, sometimes it's at the top, sometimes the problem is at the bottom. And here it is. Drainage system has no acceptable outlet nodes. So what I didn't do is I didn't make an outfall. All models need an outfall. So this is the end or the furthest downstream point of my model. So I'm going to convert that junction to an outfall, and hopefully it won't be grumpy at me now. Hooray. Hi. And this is a good time to pet your cats. That's what I do. For those of you who weren't here this morning, I adopted a feral cat about a month and a half ago, and she's finally warming up to me. She doesn't like anyone else, but she likes me, so it's a good thing. Yeah. But she bites. So once that's done modeling, or once that's done running, what I'm going to do is I'm going to create two layers. I'm going to create a flood inundation layer and a flood inundation grid layer and animate the results. So basically that's going to show us the extent of the flow. Now there is flooding. Normally you would want to investigate that. That means water is being lost in your system. So you would want to check that out. But for the sake of demonstration, I'm not going to put you through that. So I'm going to show you how to use the flood analysis tool. Just for, you don't have an exercise on this. We do, but not for this course, but to show you. So this is an easy way to either animate or show the flooding results when you don't have a 2D model. So this is just a 1D model. So I'm going to use my transects I already created. My flood inundation grid layer, I'm going to create a new one. And my flood inundation polygon layer, I'm going to create a new one. And then I'm going to click OK. So the two layers, the difference is one's a vector layer and one's a raster layer. So the vector layer is useful because it's basically an inundation polygon that you can animate, so you can see the changes over time. Where the raster layer, it's static. It just has one set of results for the peak elevation, but it has rendering, so it shows the different colors depending on the depth of water. So I'll show you what both of those products look like. And again, it's useful if you don't want to go or you don't have the time or money to put into a 2D model, but you still want that visualization. So what PCSIM is doing is it's basically interpolating what the water elevation will be in each conduit using the transects. Now that looks a little funny. So we'll start with that all about. That's funny. So sometimes you get these odd effects if your transects weren't good. So I didn't spend too much time on it, so I'm not going to worry too much, but I will show you the flood inundation polygon. So that's what this looks like. And like I mentioned, you can animate it. So you can show over time how it floods and where it floods, which is good, but you'll notice that it's all the same color, which isn't necessarily useful when you're trying to figure out where, where the deep flooding is. When you stop during an animation, the results will be reflected on the timestamp you chose to stop the animation on, and it will recalculate everything for you. Excuse me. And sometimes it takes a little while. So usually if you do have an operation that is taking a little longer, the best thing is not to get click happy. Sometimes it's very instinctual to just start clicking on things that will cause it to potentially crash. And then we have the grid, and I do apologize that looks wonky, but the grid, it does have, or it should have more rendering. It doesn't look like this is an ideal. Oh, here we are. So we have in the center here, it's a little bit darker, and then as we get to the outside, it's a little bit lighter. Also, the Z coordinate here, when you have the flood inundation raster grid, you can go over the grid cells and it will tell you that, in this case, the depth of flooding or the depth of water at that location. So there is a transect there. So it's quite useful, a neat little tool to have that visualization. You can also show the legend, get an idea of what the depths actually are referring to. And you can show people where the flooding is going to be without having that 2D model. Okay, so it is almost 10 after 8. So what I'll do is I'll stop sharing my screen. Okay. I don't see any questions.
There are no.
questions. That's okay. It's
Because this is an introduction.
pretty intro right now. Actually, I didn't want to stop sharing my screen. I should have not done that. Okay, so actually, I'll introduce you guys the first exercise. And that is the hands-on exercise. Oops. Automatic watershed.
Can you show how to download the slides too? There was a question.
Oh, yeah.
Actually, just
no problem.
under through the slides.
So the slides are right here. And it's just this little icon here. You can just click on it and then you can download it and save it
as a PDF.
As a PDF. Yeah, it is a PDF. We didn't give you the slides just because the figures are very copyrighted. But they are there for you. We will also be putting the recording up. So after the session, I will be editing to get rid of all my banter, and then I will add it right away. So you guys will have access to that. So in terms of the hands-on exercise, you guys don't have to do this if you don't want to. But if you are interested in shaking off the cobwebs and diving back into PC Swim, if it's been a little while, I do recommend it. It shouldn't take too long. And we reconvene at 10:45. I realized that the session 2, it says 10:30. It's actually 10:45. So follow the times in the session header because the Zoom doesn't let you, Zoom doesn't let you schedule something for 10:45 through this platform. So we will be doing the hands-on exercise here. You can either do this or you can take a little break, stretch your legs, do whatever you need to do, get a coffee, and we're reconvening at 10:45. If you have any questions, of course, you can ask on the discussion board. Every lesson has a discussion board. We will receive those notifications and answer as soon as we can. Or you can go through our emails. I believe Nandana put them in the chat. I'm kat@chaiwater.com and Nandana's nandana@chaiwater.com. Yeah, so good luck. If there's no further questions, what I can do is I will free you.